From the renowned Hong Kong-Zhuhai-Macau Bridge. From small urban arch bridges, we commonly see. All directly or indirectly involve pre-stress, while participating in pre-stressed anchoring and load-bearing. The protagonists of this lesson are pre-stressed anchors, clips, and connectors. In this lesson, let us learn together testing of pre-stressed anchors, clamps, and couplers. Anchors, clamps, and couplers should possess reliable anchoring performance, sufficient bearing capacity, and good applicability to ensure full utilization of the strength of pre-stressed tendons and safely execute pre-stress tensioning operations. According to the Transportation Industry Standard JT or T329, 2010, anchors and connectors can be classified by their structural forms. Two types, tensioning end anchors and fixed end anchors, as shown in figures 1:1 and 1:2. The following table 1:1 is mechanical performance requirements for anchors, clamps, and connectors. Please, during the inspection process, carefully compare and evaluate against the following mechanical performance standard requirements. Next, we proceed with learning test method for anchors, clamps, and couplers of pre-stressed tendons. Preparatory work for tests on anchors, clamps, and connectors for pre-stressed tendons. 1. Sample preparation. 1. Test preparation. Before testing pre-stressed anchor, clip, and connector assemblies, mechanical properties testing must be conducted on single pre-stressed steel strands base material. 2. Test methods for pre-stressing tendon anchors, clamps, and connectors. First, static load anchorage performance test. Test methods for clamps and couplers are basically same as anchors. The test methods introduced below all take anchors as examples. 1. Sample preparation. Number of samples. 3. Assemblies. 6 anchor rings with matching wedges and steel strands. Second, assembly. Anchor components must be cleaned before assembly. Then assemble the steel strand, anchor, and test bench, as shown in figure 1-3. Ensure uniform force distribution on each steel strand. Initial stress is 5% to 10% of the tensile strength standard value FBTK of pre-stressed steel. Gauge length for total elongation rate device should not be less than 1 meter. Third, loading. First loading rate is 100 megapascals/min. Second at 20%, 40%, 60%, 80% of standard tensile strength value of pre-stressed steel strand. Divide into 4 levels for equal speed loading. After loading to 80% of tensile strength standard value of steel strands, holding load for 1 hour. After holding load for 1 hour, slowly load until specimen failure. For measurement items during testing, first length of tension section of pre-stressed tendon. Second representative steel strands at fixed end or tensioning end. Typically take 3 to 4 pieces. Initial relative displacement value delta A. Third gauge length L1 for total elongation rate under 0.1 FPTK load. Fourth, according to the first 4 levels of applied load. 20%, 40%, 60%, 80%. Measure the relative displacement delta A of steel strands, step by step. Fifth, when the pre-stressed tendon reaches 0.8 FPTK. Holding load for 30 minutes. Slowly load until failure occurs. Measure the gauge length increment delta L1. Fifth, observation items during the test process. Observe anchor deformation. Judge after meeting static load anchoring performance. Micro cracks and longitudinal fractures are allowed in clips. Transverse, oblique fractures and shattering are not allowed. When pre-stressed tendon reaches ultimate fracture, anchor plates and their conical anchor holes are not allowed to exhibit excessive plastic deformation. The center residual deformation of the deck should not exhibit significant deflection. Sixth, recording items. Record failure location and mode of specimens. Failure location and mode of assembly should conform to wedge-type anchors and clamps, or when the clip of the connector is loaded to the highest level load. Cracks or fractures are not allowed. After meeting efficiency coefficient and total elongation rate, micro cracks and longitudinal fractures are allowed. Lateral deformation. Diagonal fractures and fragmentation is not allowed. Seventh, static load test result calculation. Static load test should continuously test 3 assemblies. Calculation required after testing. Anchor efficiency coefficient and total strain of the assembly's stress length at measured ultimate tensile force. First Transportation Industry Standard, JT, or T329, 2010, specifies the anchor efficiency coefficient is calculated as follows. Second, fatigue load test. 1. Sample preparation. Number of samples. 3 assemblies. 6 anchor rings with matching wedges and steel strands. Second, assembly. Assemble steel strands, anchors, and test platform. Ensure uniform force distribution on each steel strand. Initial stress is 5% to 10% of steel strand tensile strength standard value. Third, stress amplitude, test stress upper limit. First stress amplitude should not be less than 80 megapascals. Second test stress upper limit is 65% of steel tensile strength standard value FPTK. Fourth, pulse frequency cycle count of fatigue testing machine. First, the pulse frequency of the fatigue testing machine shall not exceed 500 times or min. Cycle count of 2 million times. Fifth, loading. According to the testing machine used, load at approximately 100 megapascals/min until reaching the stress upper limit. After readjusting the stress amplitude to the specified value, begin recording cycle count. Sixth, test results. First, describe the sample after enduring 2 million cyclic loads. Whether fatigue failure occurs in anchor components. Describe cross-sectional area where pre-stressed tendon experiences fatigue failure in anchor clamping zone. Finally, we will learn how to evaluate test detection results. Static load anchorage performance test. First, during anchor static load test, if test values fail to meet eta A is greater than or equal to 0.95 epsilon APU is greater than or equal to 2%. If steel strand fractures at non-clamping locations outside anchor, clamp, or coupler, replace the steel strand and resample for testing. Second, during static load testing of anchors, although test values meet eta A is greater than or equal to 0.95 epsilon APU is greater than or equal to 2%. When the anchor fails due to fracture, then the test results are judged as unqualified anchors. 2 out of 3 assemblies do not meet the requirements. Then the batch of products is judged as unqualified product. If any assembly does not meet the requirements, double the number of samples should be taken for retesting. If there are still those that do not meet the requirements, judge the batch of products as unqualified product. If fatigue load performance is unqualified, the type inspection is directly judged as unqualified. In this lesson, we mainly studied: first, content and methods for mechanical performance testing of pre-stressed anchors, clamps, and couplers. Second, product classification of pre-stressed anchors, clamps, and couplers. Through the learning in this lesson, hope you in future work learn to distinguish test and inspection methods for anchors, clamps, and connectors. and possess the professional quality and spirit of a bridge inspector. In future work, be rigorous, practical, and meticulous. After class, please consider the following questions. First, why conduct mechanical performance testing of steel strands before test? Second, whether test detection methods differ for various anchors, clamps, and connectors.